Hello friends, now we are starting next article from this chapter, that is skew lines. Skew lines are also called as what? Non-coplanar lines. Try to understand what is the meaning of skew lines. Before that, let us discuss about parallel line. Already you have studied about what? Parallel line. If two lines which does not intersect each other, at that time two lines are called as what? Parallel lines. And if two lines are parallel, then there exists one plane which passes through what? These two parallel lines. Plane means what? A flat surface. So there exists one plane which passes through two parallel lines. If these parallel lines are in this form, then there exists one plane which passes through what? These two parallel lines. Means two parallel lines are always what? Coplanar. Now let us suppose that these two lines are what? Intersecting lines. These two lines are intersecting. If two lines are intersecting, then there definitely exists at least one plane which passes through what? These two intersecting lines. Means two intersecting lines are also what? Coplanar. Now let us suppose that these two lines are what? Parallel to each other. Now if we are changing the direction of one line, so we can observe that these two lines are what? Not intersecting and neither parallel. So these two lines are neither parallel nor intersecting. So we can say that there does not exist at least one plane which passes through what? These two lines. Because if first line lies in one plane, suppose that this plane, then definitely this second line does not lie in this plane. Means if two lines are neither intersecting nor parallel, at that time the lines are what? Non-coplanar. That's why we can say that a pair of lines in a space which are neither intersecting and nor parallel, at that time two lines are skew lines, or we can say that skew lines means what? Non-coplanar lines. Means there does not exist one plane in which two neither intersecting nor parallel lines lies. Means in short, if two lines are neither intersecting nor parallel, at that time two lines are called as skew lines, or skew lines are what? Non-coplanar lines. Means if question is asked to show that two lines are skew lines, means you have to prove that skew lines or two lines are non-coplanar line. At that time you have to prove that the two lines are not intersecting and two lines are what? Not parallel. Means if lines are neither parallel nor intersecting, such lines are called as what? Skew lines. Now we are discussing one very important formula. So this is theorem 6.6. In this case, equation of two lines are given to us, and we are discussing a formula to find out distance between these two lines, where these two lines are what? Skew lines. Means in short, we are discussing a formula to find out distance between two skew lines. So let us try to prove this formula. So what is the equation of first line? R bar is equal to a1 bar plus lambda 1 b1 bar, and second equation is r bar is equal to a2 bar plus lambda b2 bar. Both the equations are given in vector form. So in this case, just by observation we can say that the first line passes through what? A point whose position vector is a1 bar. So let us denote this first line by L1. So already this first line we are denoting it by what? Be the equation of which line? L1. Now this line passes through one point whose position vector is what? A1 bar. So we are supposing that that point is nothing but what? A, whose position vector is what? A1 bar, and this line is parallel to which vector? B1 bar. So already all these things we have shown in the figure. So A1 bar is the position vector of point A, and this line is parallel to which vector? B1 bar. Now consider the second line. R bar is equal to A2 bar plus lambda 2 B2 bar. So in this case, here A2 bar is nothing but position vector of a point on this line. So point on this line we have denoted by B, and we are supposing that its position vector is what? A2 bar. And this second line is parallel to which vector? B2 bar. So we can say that B2 bar is a vector parallel to this line, or it is a vector along the line. Well, we have denoted first line by L1 and second line by what? L2. Now what we are discussing? Distance between two lines. So let us denote this distance between two lines by what? PQ. So if I am saying that let PQ is a segment perpendicular to both lines L1 and L2. So means PQ is nothing but perpendicular distance between these two lines, isn't it? So if I am saying that PQ is perpendicular to L1 also and L2 also, means this is nothing but distance between these two lines. And question is to find out distance between two lines, which we are denoted by what here? PQ. Now what is the given condition? Observe the given condition here. B1 bar is a vector parallel to first line, or we can say that B1 bar is a vector along first line. In other words, we can say that it is vector along the line or it is vector parallel to the line. Now PQ is perpendicular to L1, means we can say that this B1 bar is also what? Perpendicular to L1. In the same way, PQ is perpendicular to line L2, means we can say that this PQ is perpendicular to which vector? B2 bar, or B2 bar is perpendicular to what? PQ. Means what we are getting here, PQ is perpendicular to both the lines, means we can say that PQ is perpendicular to what? B1 bar and B2 bar. So therefore PQ is perpendicular to B1 bar and B2 bar. Now let us suppose that here this will be say segment PQ, and B1 bar is also vector perpendicular to PQ and B2 bar is also vector perpendicular to what? PQ. If these two vectors are perpendicular to PQ and if we are taking cross product of these two vectors, we will get a new vector. Which new vector? B1 bar cross B2 bar. We know that B1 cross product of two vector is a new vector which is perpendicular to B1 bar also and B2 bar. Means this vector is perpendicular to B1 bar also and B2 bar also. Means we can say that B1 bar cross B2 bar is parallel to what? PQ. So therefore B1 bar cross B2 bar is parallel to what? PQ. PQ, or we can say that it is parallel to PQ bar, or you can say that it is parallel to what? PQ. So here if we are taking cross product of these two vector, we will get a new vector which is parallel to what? PQ. So let us draw here one vector B1 bar cross B2 bar which is parallel to what? PQ. So this vector B1 bar cross B2 bar is parallel to what? PQ. Means it is perpendicular to B1 and perpendicular to B2 also, because cross product of two vector is new vector which is perpendicular to B1 bar also and B2 bar also, means it is parallel to what? PQ bar. Well, now we have got one vector. Now this vector is parallel to what? PQ bar. We are able to draw this vector anywhere, but to prove our required result, I am constructing this vector through this point A. For simplicity, because we are studying about what? Free vector. So this vector can be moved anywhere without changing its magnitude and what? Direction. Okay. So now here we can, if a perpendicular is drawn from point B on this PQ, perpendicular is drawn, try to understand it very carefully. So one perpendicular is drawn from point B on which vector? B1 bar cross B2 bar. Then we have to check whether PQ is the projection of this AB bar on this B1 bar cross B2 bar or not. For that purpose, let us revise the definition of what? Projection. Let us suppose that this will be say one vector here. Let this will be say vector B bar and this will be say vector A bar. Okay. Through the terminal point of this vector A bar, draw a perpendicular. Let their initial point is say O. Through the terminal point of A bar, draw a perpendicular on B bar. Then this OM is called as projection. Projection of A bar on what? B bar. So in this case, through the terminal point of AB bar, means through point B, a perpendicular is drawn on which vector? B1 bar cross B2 bar. Then this length is called as what? Projection. But if you observe here, if you are draw this segment here, so here in this quadrilateral, three angles are of 90 degree, means definitely fourth angle is also of what? 90 degree, because sum of four angle is equal to 360 degree. Means we can say that this quadrilateral becomes what? Rectangle, since all the angles are of 90 degree. And what is the property of rectangle? Opposite sides are equal, means we can say that PQ, this length of PQ and this projection of AB bar on what? B1 bar cross B2 bar are of equal length. Are of what? Equal length, means in short, this projection of AB bar on B1 bar cross B2 bar means this segment, and this segment is equal to what? PQ. That's why in simply we can say that PQ is projection of AB bar on what? B1 bar cross B2 bar. So here we can say that PQ is equals to projection projection of AB bar on B1 bar cross B2 bar, isn't it? And if A bar and B bar are two vector, then projection of this A bar on this B bar can be found out applying which formula? A bar dot B bar upon magnitude of B bar. Applying this formula, we are able to find out projection of what? A bar on B bar. Same formula we are applying here. So which is equal to, here we are finding projection of AB bar on B1 bar cross B2 bar. So here in the numerator, take the dot product of these two vectors. Just now we have taken dot product of A bar and what? B bar. So here A bar dot B bar, AB bar dot B1 bar cross B2 bar. We have taken dot product of these two vectors divided by magnitude of B bar. Here B bar is nothing but what? B1 bar cross B2 bar. B1 bar cross B2 bar. Applying this formula, what we are able to find out? Projection of A bar on B bar. Same formula we have applied here. Just A bar means what here? AB bar, and B bar means what here? B1 bar cross B2 bar. So which is equals to, so now this AB bar in terms of position vector can be written as, we know that AB bar can be written as what? AB bar in terms of position vector can be written as B bar minus A bar, where B bar is position vector of point B and A bar is position vector of point A. But here position vector of point B is denoted by what? A2 bar, and position vector of point A is denoted by A1 bar. So instead of B bar minus A bar, what we'll get here? A2 bar minus A1 bar. So AB bar can be written as what? A2 bar minus A1 bar, because position vector of point B is A2 bar and position vector of point A is what? A1 bar. Dot B1 bar cross B2 bar, keep it as it is. And in the denominator, B1 bar cross B2 bar, also keep it as it is. Applying this formula, we are able to find out what? PQ. And PQ is nothing but what? PQ is nothing but distance between these two lines. In this way, we have got this formula to find out, so divided by magnitude of B bar, sorry, here magnitude is there. So applying this formula, we are finding distance between 2 points. So to apply this formula, which values are required? B1 bar, B2 bar, A1 bar, A2 bar. All these values we will get from the equation of two lines. From the equation of first line, we will get A1 bar, B1 bar. From the equation of second line, we will get A2 bar and B2 bar. If the values of these four vectors are known to us, this formula is applicable to find out shortest distance between two lines, or in other words, we can say that distance between two lines. So in this way, we have proved the very important formula to find out distance between two lines. Some of the important results which you are getting from the theorem, so note down those results also. So now, just now we have proved this important formula to find out shortest distance between two lines, means to find out distance between two lines, or in other word, we can say that this formula is applicable to find out what? Shortest distance between two lines. Now, if two lines intersect each other, let us suppose that these are two lines. If these two lines intersect each other, then shortest distance between them is equals to what? 0, because these two lines are intersecting lines. So here we are saying that the two lines intersect each other if and only if the shortest distance between them is equal to what? 0. Means if shortest distance is 0, at that time we can say that lines are intersecting, or if lines are intersecting, at that time we can say that shortest distance is equal to 0. Now we are finding one condition, that if these two lines what? Intersect each other. If these two lines intersect each other, at that time we can say that this shortest distance is equals to what? 0. So this is the formula to find out shortest distance. But in case if these two lines intersect, this shortest distance is equal to what? 0. So this term in the denominator will get multiplied on this side. So if it get multiplied to 0, what will get on the side? Right hand 0. Right hand side will become 0. And what is the term, remaining term on the left hand side? A2 bar minus A1 bar dot B1 bar cross B2 bar is equals to what? 0. This term will get multiplied on this side. So this side will become 0. So remaining term on this side is nothing but numerator. When this condition is satisfying, if two lines are what? Intersecting. So if two lines are intersecting, at that time which condition is satisfying? A2 bar minus A1 bar dot B1 bar cross B2 bar is equal to 0, means shortest distance is equals to 0 if two lines are what? Intersecting. Using that, we have got this result. Okay, so this condition is applicable if two lines are intersecting. Now here equation of two lines are given in which form? Vector form. Instead of vector form, if equation of two lines are given in Cartesian form, at that time we are discussing a formula to find out or we are discussing a condition which is satisfying if two lines are in Cartesian form and are intersecting each other. So well, now if you'll observe this first line, a1 bar is what? Position vector of one point on the line. Here, what is the coordinate of a point on the line? x1, y1, z1. Means what will the value of a1 bar? a1 bar will be equals to x1 I cap plus y1 j cap plus z1 k cap. So from equation of line, we will get the coordinate of one point on the line, and from that coordinate we are able to find out value of position vector of that point using that coordinate, isn't it? Now what is this a2 bar? a2 bar is the position vector of one point on the second line. What is the coordinate of a point on the second line? x2, y2, z2. Then what is the value of a2 bar here? a2 bar will be equals to x2 I cap plus y2 j cap plus z2 k cap. So well, value of a1 bar and a2 bar we will get from this equation, isn't it? Now we are trying to find out value of b1 bar and b2 bar. So b1 bar means what? It is the vector along the line, or in other word we can say that it is vector parallel to the line. So what is the direction ratio for which we are getting from this equation? These values in the denominator a1, b1, c1 are nothing but what? Direction ratios of the line. So if direction ratios of the line is known to us, then vector along the line is nothing but what? a1 I cap plus b1 j cap plus c1 k cap. From this direction ratio we will get the vector along the line first, a1 I cap plus b1 j cap plus c1 k cap, and b2 bar is nothing but vector along the line second, vector along this line second. So what is the direction ratio of second line? a2, b2, c2. Then value of b2 bar will be equals to a2 I cap plus b2 j cap plus c2 k cap. So in this way, from these two equations we have got the values of a1 bar, a2 bar, b1 bar, b2 bar. Already we have got one condition which is satisfying if two lines are what? Intersecting lines. If you'll observe this condition, this is first vector, this is second vector, this is third vector. First dot is there, then cross is there, means it is scalar triple product, and we know that value of scalar triple product is nothing but what? Determinant. Keep the right hand side 0 as it is. Is it clear? Value of scalar triple product is nothing but what? Can be find out using determinant. In the first row we are writing coefficient of I cap, j cap, k cap from the first vector. Which is the first vector? a2 bar minus a1 bar. So check what is the coefficient of I cap in a2 bar minus a1 bar. So x2 minus x1 will be the coefficient of what? I cap, x2 minus x1. Now try to find out coefficient of j cap. So in which vector? a2 bar minus a1 bar, means here we will get y2 minus y1, y2 minus y1, and coefficient of k cap will be equals to, what is coefficient of k cap? z2 minus z1, z2 minus z1. In this way we have got the element of first row from this first vector. Now in the second vector write down the coefficient from what? b1 bar. What are the coefficient of b1 bar? a1, b1, c1. And in the third row write down the coefficient of third vector b2 bar. What are the coefficients here? a2, b2, c2. And this is the condition which we are applying if two lines are what? Equation of two lines are given in Cartesian form and these two lines are what? Intersecting. Then this condition is satisfying. So well, we have got this condition applying this result. Now not necessary how we have applied this condition. Now you have to remember that this will be the condition which you are applying or which is satisfying if two equation of lines are in Cartesian form and these two lines are what? Intersecting. Getting it? So if the equation of two lines are given in Cartesian form and if the lines are not intersecting but question is asked to find out distance between two lines, then from first equation try find out a1 bar, b1 bar. From second equation find out a2 bar, b2 bar. Once these values are known to us, apply this formula to find out shortest distance between two lines. But if lines are intersecting, directly you are able to apply this condition. From these two equations you will get 12 values. From first equation you will get x1, y1, z1, a1, b1, c1. From second equation you will get x2, y2, z2, a2, b2, c2. And these 12 values are required to apply this condition. In this way, In today's lecture, we have proved one very important formula to find out shortest distance between what? Two lines. And even we have discussed the conditions for lines to be what? Intersecting. We have got the conditions for line to be intersecting in vector form also and in Cartesian form also. So well, in the next video, we will discuss one very important formula to find out distance between two parallel lines.